Why are materials so crucial for high-temp heat engines? Imagine trying to run an engine at temperatures hotter than boiling water without the right materials. It would be like trying to cook with a pot that melts. That's why materials are so important in high-temperature heat engines. These engines, like gas turbines and advanced internal combustion engines, operate under extreme heat and stress. The hotter they run, the more energy they can produce from the same amount of fuel. This means better fuel efficiency and fewer emissions. But to reach those high temperatures safely, the engine parts need to withstand incredible conditions. Materials used in these engines must have very high melting points, often exceeding 700 degrees Celsius and sometimes going beyond 1200 degrees Celsius in the most advanced engines. If the materials melt or deform, the engine fails. That's why engineers choose special alloys like nickel-based superalloys. These materials stay strong and stable even at very high temperatures. They also resist oxidation and corrosion, which happen when hot gases react with metals and cause damage over time. This resistance is vital because it keeps the engine parts intact during long periods of operation. Another key property is thermal stability. Materials must handle repeated heating and cooling without cracking or losing strength. They also need low thermal expansion, meaning they don't change size too much when temperatures fluctuate. Mechanical properties like tensile strength and creep resistance are equally important because engine parts face constant mechanical loads. If the materials aren't tough enough, they can crack or wear out quickly. In addition to the base materials, protective coatings are often added. These coatings act like shields, helping materials resist heat and oxidation even more. For example, thermal barrier coatings are used on turbine blades to keep the metal underneath cooler and protected. Developing these advanced materials and coatings is a major focus in mechanical engineering. Small improvements in material properties can lead to engines that run hotter, last longer, and perform better. Without materials that can handle such harsh conditions, engines would break down prematurely. They would be limited to lower temperatures, which means less power and efficiency. That's why selecting the right materials, designing them carefully, and improving them constantly are essential for pushing the limits of what high-temperature heat engines can do. This progress benefits industries like aerospace, automotive, and power generation, where every bit of efficiency counts.